everyone. In this video, I'm going to be covering the topic of data cleaning. So data cleaning is usually the biggest, most time-consuming, and sometimes annoying part of a data analysis project. So let's get into what is meant by data cleaning. We'll talk about that in this video. We will talk about what's the purpose. Why do we need to clean the data? Why do we need to waste so much time doing all this tedious work? What are the common problems that we are seeing in dirty data sets or data sets that have not been cleaned? And what are the issues with those problems? And what does data cleaning involve exactly? Like, practically speaking, what exactly do you have to do to get an uncleaned data set to be clean? Now, in this video, this is more of just getting you to understand the purpose, and I guess like the concept, the impact of cleaning data or not cleaning data. I will show you some examples, but we are not actually going to be data cleaning in this video. That will be done in a separate lesson. Okay, so first, you need to understand what is data cleaning. What is the definition? So if you look in any business analytics textbook, the definition is going to be something like this that you see on the left. Data cleaning is the process of preparing data for analysis by weeding out information that is irrelevant or incorrect. It is also called data cleansing or data preparation. So here we're really trying to make things look prettier. We are trying to remove any errors. Essentially, at the end of the day, though, we are trying to get our data ready to have statistical tests or descriptive statistics done or calculated. Different sort of tests require your data to be arranged in different ways. So sometimes your data is not necessarily unclean. There aren't necessarily errors, but you're just needing to kind of rearrange things so that you can do the analysis. So the key actions involved in data cleaning. First, we are removing chunks of unnecessary data. In every just raw data set, I say every, probably 99.9% of raw data sets have data that you're not necessarily going to use in your analysis. So it might be variables. If you're thinking of an Excel spreadsheet, it might be columns that are useless to you. Remove them. It could be rows of data that are useless to you. So you might have to remove those. There might just be inaccurate data in there that needs to be removed as well. You're fixing errors. So, sometimes incorrect entries or typos are in there and you can just fix them. It's not like you have to remove the entire case. You're just going to correct them. Reducing duplicates is another common issue. So if you're studying people, the same person might be in your data set several times, which violates an assumption of many of the statistical tests. And just gives you completely inaccurate findings. So you're going to remove duplicates. Those are just a few of the key actions, but we will go through a long list of all of the actions involved. Now, a lot of people think data cleaning is done in Excel, and you would be right. A lot of times data cleaning is done in Excel, but it can be done across different types of analytical programs or software. So R and RStudio, that is a great tool to use for data cleaning because you're writing the code which is cleaning the data for you, and that code is sort of a way of documentation. So you can always go back and look at your code to see what was done. In Excel, it's not that simple. So you have to document everything that you do when it comes to data cleaning in Excel so that you don't forget what you did or why you did it. So why is it important to clean data? So first of all, readability. So when you have a clean data set, your data set is easier to read, or your statistics make sense. You can get the statistics, some accurate statistics. It's easier to navigate and interpret. Consistency. So uniform formatting, the way things are named needs to make sense and be consistent across data sets or across the company with the way the variable names are used. And then structured variable logic. Just all of your variables need to be consistent and make sense and logical. Accurate results. So we need to clean data because obviously our statistics are not very useful to us if they're inaccurate, and our statistics will be inaccurate if our data is inaccurate. So we've got to make sure our data is accurate in order to get those insights, those accurate insights. That is the whole purpose of data analytics. So data cleaning prevents skewed metrics, faulty statistical models, and misleading conclusions. And that leads to better decision making. So we clean data so ultimately we can have better decisions made. So it enables leadership to make confident, evidence-based strategic decisions. And like I said, your data needs to be cleaned or prepared for analysis. So part of the data cleaning process is to prepare the data to be analyzed. So for instance, I want you to think back to the analysis of variance hypothesis test. So with this test, we are comparing different groups on some quantitative outcome. We're looking to see if they have significantly different means group to group. Now, a lot of times, your group names are in one column in a data set. So you might have a variable with the groups and then another variable in the data set with their outcome that you're interested in comparing. You have to manipulate the data such that each group has its own column in Excel, and then you are putting their data underneath their new column. So that's a way of like flipping things from being in more of a column or a row format into a grouped column format, if you will. And we'll go through that later on in the class. But that's one example of just how you would, even though your data might be clean and correct, you still have to change it a bit to prepare it to be analyzed. Okay, so before you begin cleaning the data, there are a few things that you should do. First, plan your analysis. Make your analysis plan. I've seen this happen multiple times where my students jump to data cleaning before they actually think through what statistical tests am I going to be conducting to answer the business question, and what data visualizations am I going to be creating. They jump to data cleaning and they do a whole lot of unnecessary work. They make sure every variable, every column in the data set is clean. Then what happens is when they get to their analysis, they're realizing that a lot of that work that they did was unnecessary because they're not even using those variables in their analysis or in their visuals. So step one is, what's your analysis plan? You need to have that analysis plan, which is really just what are the statistical tests you're conducting? What are the data visualizations that you're building? And once you have that statistical test figured out, and the data visualization figured out, then you're thinking through what's useful in my data set, what can I remove, and how does that data need to be arranged. Okay, so then business question first, and this kind of relates to step one. Never clean data aimlessly. The business objective determines what you need and how it must be arranged. So not every variable needs to be cleaned or included. You can delete some variables from your data set. And step three, the variable definition. So make sure you understand what each variable actually represents. Look through all the variables in your data set before you do anything. Make sure you understand what they are, and if you don't, find somebody that knows what they are and ask a lot of questions. So do that before you change anything with your data set. You need to make sure that the data set can be trusted before you use it for analysis and making critical business decisions. Okay, so let's just take a look at a data set that is not clean. So this is a data set that is not clean. This is a very simple data set of 30 rows. So we have column A is customer, and the various stores that they purchased from. Column B is their state. Column C is sales, and column D is the order date. So what is wrong with this data set? I want you to look at it and think about what seems not clean. Okay, so first, we have inconsistent state formatting. That's very obvious if you just look at row 1 and 2 and 3. So we have Louisiana, LA, and then Louisiana written out. So that's an issue because if you're wanting to just create a quick pivot table to get like the averages from Louisiana or the sum from Louisiana, that's going to not be so easy to do because on the pivot table, you're going to have LA and Louisiana. So that needs to be corrected to where Louisiana is just a consistent name, however you choose to name it. You have the same thing going on with Texas and California. Second, look at order date. So it's in various formats. So all of the dates need to be in the same format. Third, we have inconsistent casing and missing data. So similar type of thing in column A, Walmart is capitalized versus uncapitalized. So that needs to be corrected. And under sales, you'll see some missing data here. And then we have invalid sales and duplicates. So we have a couple of negative sales values, which doesn't really make sense. Or, maybe it does in a way, but we don't really know what that means. So we would need to find out. Also, what is the unit of sales here? Is this in thousands? I would also add dollar signs to make sure it's being read as currency. And we do have duplicate rows. So I know that's hard to notice at first glance, but for instance, row 13 and row 15, that appears to be a duplicate. So if you look throughout here, there are several. Okay, now let's look at two other data sets. So this is actually the same data set, but on the left, we have the uncleaned data set, the raw data. On the right, we have the clean data set. So you will see that I went ahead and pointed out the error for you in these two data sets. So you will see it circled in red. On the left, there were 3 zeros under this satisfaction variable. Well, if you are familiar with the satisfaction variable, then you would know that the options were 1 to 10. A 0 wasn't even an option on the satisfaction scale. So if you even just search the min of that variable, you would see a 0, you would say, okay, something's not right. So, after further digging, what's the correct data here? Those actually should have been 10s. So in the clean data set, those zeros were changed to 10s. Now I want you to think about what this means. What would your conclusion be? And let's talk about this data set a little more. We have 24 customers and we have 3 stores. So they went to one of 3 stores. We have store A, store B, and store C. We want to compare their satisfaction levels. So if you're comparing customers across those 3 stores, the unclean data set, you're going to get a grand mean of 7.33. The mean for store A is 8.43. The mean for store B is 7.43. And then the mean for store C is 6.50. But like I said, these 3 values were incorrect and they're zeros. So over here with the clean corrected data set, our grand mean changes to 8.58. And then our mean for store C changes to 9.50. So take a second and think about how your conclusion would change with these numbers. Yeah, so at first in the unclean data set, it looked like store C had the least satisfied customers, when actually, with our cleaned, corrected data, store C had customers with the highest level of satisfaction. So our conclusion's totally different. So this is why it's critical to make sure that you're working with cleaned data. Okay, so what are some common data problems? What do we actually need to do when we are cleaning data? So first, we are going to check for missing values. Okay, where are our missing values in our data set? Look for blank cells, look for missing records, and investigate why it's missing. Is it just randomly missing, or is it missing for a legitimate systematic reason? So your options here are to just leave it missing, to remove the case entirely, or to impute, meaning to kind of like fill it in with maybe the average. Never auto replace with a zero. So if you have missing data, think about if you put a zero in that missing cell, think about how that would throw off your calculations. I just showed it on the previous slide. It completely throws off your calculations and everything ends up being inaccurate. So never plug in a zero where you have missing data. Also, if you're using VLOOKUPs, which we'll cover in a little bit, but you're probably all pretty familiar with VLOOKUPs. If there was missing data, what you're trying to VLOOKUP in, it could pull it as a zero. That's something to watch out for. So just always check what your VLOOKUP has pulled in. If it pulls in a zero, make sure that's accurate. 2, okay, duplicates. We need to check to see if we have duplicates, and if we do we need to delete them, or are they legitimate repeats that we want to include in our analysis? A lot of times we do want to delete the duplicates. And what I mean by duplicates, same customer or same order, for instance, or same location. It just depends on what's the population you're looking at, appearing multiple times in the data set. In Excel, it's going to look like multiple rows that have the same exact information in them. Okay, number 3, inconsistent formatting. So like I showed you in the data set with the list of states earlier, there were different ways Louisiana was entered into the cells. So you want all of that to be consistent. That's, it's going to make the analysis easier to do. Same thing could occur with gender, M versus male. You also could have sometimes, male versus female is entered as a number. So you just want to make sure all of that is consistent. Date formats, I showed you that. Having extra spaces, sometimes there's like a trailing space that is either before the text in a cell or after. You want to be careful about that. Phone numbers, etc. So you want to make sure everything is formatted in a consistent way. And then incorrect data types, number 4. This can be an issue when numbers or dates are stored as text strings. So whatever software program that you're using, you want to see how the data is being considered. Like, what is the data type that program has that listed as? So in Excel, for instance, there's a little drop down in the center top of the screen. If your data is currency, make sure it's being read as currency. If it's date, make sure it's being read as date, etc. If it's a percentage, make sure it's being read as a percentage. Okay, number 5, check for impossible or invalid values. So a lot of times this is from just simple typos. For instance, you could have negative age or negative sales like we saw in the data set earlier. You could have an age that is just very unlikely, like a 150-year-old customer. You could have too many months in a year, or a sales value that is just, not quite possible for the business. I've also seen like safety incidents issues in data sets, like way more safety incidents than would make sense. I've seen that happen. Number six, for outliers. So you want to check your outliers. Now, outliers are unusually high or unusually low values. Sometimes they are true outliers that do not need to be deleted, and you want to include them in your analysis, but they also can be an indication that that data is not accurate. So, how do we determine if something is an outlier? So, one simple rule of thumb is to use a z-score. So hopefully you remember from the statistics class, your z-score is that value minus the mean divided by the standard deviation. So it tells you how far your value is from the mean in terms of the standard deviations. So if your z-score is above 3 or below -3, that's telling you that that value is really, really far from the mean. So those are the values that you really want to check. So you can just convert all of your values into z-scores very easily in Excel, and then just look and see which ones are falling out of that -3 to +3 range. Number 7, you're going to check for inconsistent units. So I've seen this happen where, for instance, in sales variables, you have things in thousands versus not in thousands. So you want to make sure your units are consistent. Mixing like pounds and kilograms, or Fahrenheit versus Celsius, or whatever it is, you want to make sure all your data is in the same unit for each variable. And then 8, inconsistent definitions. So making sure everyone in the company that's using the data or discussing the results understand what the variables are, what you mean as a customer or a sale or revenue. Does that include returns or does it not? Definitions can shift across time and across different members of the organization. And then 9, having data located across different sources is very, very common. A lot of times you'll have one variable in one data set that you need and another variable in another data set that you need, and you want to do an analysis with both of the variables because you might want to see if one predicts the other. That is almost always the case, that they're in different data sets. So you do have to merge the data sets. You have to pull those variables all into the same data set. They can be stored across different platforms or files. So you might just have your data in 2 different Excel sheets that you need to combine into one, or you could have some data in Excel, some in an SQL database, some in an online survey. You have to bring it all together. So merging data sets does require a common identifier for each case. So you can merge the data set based on that common identifier. So for instance, like customer ID or product ID or employee ID. That's what you're going to use to merge the data. Okay, and then at the end, you want to do some sort of audit to make sure that the merge was correct and you don't have any errors there. So inspect the data set after the merge. Did total observation count change as you would expect or in a way that makes sense? Did any critical records just disappear when you didn't want them to? Were unintended duplicate records created? And did any key variables suddenly disappear when you didn't want them to? So this kind of sums everything up that I just discussed. This is a data cleaning checklist, and you might want to just save this slide or print this slide out because you're going to have an exercise where you're going to have to go through data cleaning, and you're also going to have to do data cleaning for the project. So you're just going to want to check off this list. So for data cleaning, we are going to merge data sets with common IDs. We are going to create dummy coding where needed. So I haven't discussed dummy coding yet, but dummy coding is where if you are looking at certain groups that's falling in one column, you are going to add a new column for each of those groups. And if that case falls in that group, you're going to put a 1 in this new column. If not, you're going to put a 0. So, for instance, let me go back to this data set would be fine. So for dummy coding, you would basically create 3 for this data set. Let's say that you wanted to compare store. You wanted to see if store had an impact on satisfaction, and say you wanted to use an analysis like a regression. You would have to do something called dummy coding, and we'll talk more about that. But just to explain dummy coding to you, you would create 3 columns to represent each store in another sheet. You would have store A would be one column, store B would be the other column, and store C would be the other column. Then you'd go through customer to customer to customer, and if that customer is in store A, then in that new store A column, you would put a 1. If the customer did not fall in under store A, so if they fell under store B, you would have a 0, and you would do that for each of those columns. I will show you this in a demonstration. I know that's a little confusing without walking you through it, but that's just kind of the basics of what it is. You're taking categorical data and you're giving each category its own column, and then you're assigning 1s and 0s under it based on whether the case fell into that category or not. So that's dummy coding. Converting text to numbers. So oftentimes, you need to convert text responses to numbers. So for instance, on like a survey agreement scale, if your data is like strongly disagree, disagree, neutral, agree, strongly agree, you're going to want to convert those to numbers 1 through 5, numbers that make sense. But when you do that, make sure you also create an index in your documentation pointing out exactly what each number means. You're also going to rename any confusing or complicated variables. So you're going to go across the top of the data set. Any variable names that are too long or confusing or difficult to read, rename them. Okay, so then here under quality and outliers, you're going to check for missing data like we discussed already. You're going to look for outliers and determine if you're going to delete the outliers or if they're meaningful. You are going to check for errors, typos, and formatting issues. And you're also going to look for variables with 0 variance. If everyone in the data set has the same exact response under a variable, that variable is not useful in any sort of analysis. Okay, and then hygiene and cleanup. Identify strange names or invalid values. Ensure all variables have proper names. Sometimes a variable doesn't have a name at all at the top of the column, so it needs to have a name. Or you'll get some errors when you're trying to do pivot tables or other statistical tests, or you'll just be confused. And then check for and eliminate duplicate records and delete useless or redundant variables. So that is our data cleaning checklist. And I feel like I'm always tweaking this and adding to it. So if I make any major changes to it, I'll send you a new copy. Okay, data validation. So at the very end, we have some data validation that we need to do. Put this back in presentation mode. We are going to inspect the data before we're even using it. Well, I said at the end, at the beginning. So at the beginning, we are going to inspect the data before using it. We are going to check how many rows do we have, how many columns do we have, what are our variable names, what are the data types. We're going to calculate some descriptive statistics because sometimes that's an indicator that there are errors in the data set. So we're going to look at the mean, the median, the min, the max. Does the min and max make sense? Standard deviation and counts or frequencies. Build some visuals. even if you're not going to present them to anyone. Sometimes looking at a visual of what's going on in the data helps you figure out if the data makes sense and kind of what's going on. So we'll cover data visualizations in a future lesson. So then, does the data make sense? Does the data set tell a believable, coherent story? And then just based on what you know or based on what other people in your business know, do the numbers seem to match what they know? Or are there sudden, unexplained shifts requiring investigation? And 3, essential rules. Like I said, make sure you are documenting everything. Log every step you've taken in the data cleaning process, and also maybe include why you made those steps. You can do this in just a Word document. Wherever you want to log it, just make sure it's logged. Or add another tab in an Excel workbook and just make those notes in another sheet. Like I said, make sure you're creating an index for recoded text or unit changes. And then also, never overwrite raw data. Save your raw data as, one version. And as you make major changes to the data set, you might want to save various versions. That way, if you ever make an error or you have a question about what it originally was, you can go back. If you have any questions about this lesson, please direct your questions to my email here. And thanks for watching.